The Atlantic Ocean's deepest point is moving, not drifting, moving. And people monitoring the Puerto Rico Trench just detected something that's rewriting their understanding of how Caribbean earthquakes work. In 2025, a magnitude 4.2 earthquake struck directly above the trench. This was the 47th earthquake in that exact location in 3 weeks. The pattern wasn't random, it was actually organized. Sequential, every tremor occurring 3 to 4 kilometers deeper than the previous one, like dominoes falling in slow motion toward the ocean floor. Dr. Elizabeth Vanacore, lead seismologist at the USGS Caribbean Network, pulled up the clustering data and saw something that made her breath catch. The signature was identical to pre-rupture sequences recorded before Japan's 2011 Tohoku earthquake, before Chile's 2010 Megaquake, before every major subduction zone disaster in recent history. The Atlantic's most dangerous fault isn't just active, it's waking up, and what happens next could reshape the entire Caribbean. Let me explain what makes the Puerto Rico Trench absolutely terrifying. We know most subduction zones on Earth follow predictable rules. The Pacific Ring of Fire, for instance, operates like clockwork. Denser oceanic plates slide beneath lighter continental plates at relatively consistent angles. Scientists can model these interactions with reasonable accuracy. The Puerto Rico Trench plays by different physics entirely. It's what geologists call an oblique subduction zone. The North American plate isn't diving cleanly beneath the Caribbean plate. Instead, it's grinding sideways while simultaneously being forced downward. Imagine two massive puzzle pieces that don't fit, being jammed together at a 20-degree angle. This creates multiple rupture pathways. A single earthquake here can trigger thrust faults, strike-slip faults, and transform boundaries simultaneously. Energy releases in unpredictable bursts across different fault segments. The result would be earthquake swarms that behave more like geological infections, spreading from one fault system to another in cascading sequences. Recent seismic tomography reveals even more complexity. Beneath the main trench, at depths exceeding 150 kilometers, there's a massive slab tear. Part of the North American plate has literally ripped apart under the immense stress, creating a three-dimensional maze of fractured crust. This very crust channels stress in directions standard models never anticipated. The story gets strange from here. GPS arrays positioned across Puerto Rico detected something in late 2024 that hadn't been seen before. The island wasn't just moving northeast at its expected rate of 19 millimeters per year, it was accelerating. By January 2025, some stations were recording movement rates of 24 millimeters annually. That might sound minor, but in geological terms, it's the equivalent of slamming on the accelerator. Let's go back to December 2024. While tourists celebrated the holidays on San Juan's beaches, seismic stations recorded 190 earthquakes in a 72-hour period. Most were magnitude 2.5 or smaller. Too weak to feel, too subtle to make headlines. But the pattern, they formed a line. A nearly perfect arc stretching 45 kilometers along the trench's southern wall. Every tremor occurred roughly 3 to 4 kilometers deeper than the previous one, like dominoes falling in slow motion into the abyss. Dr. Vanacore's team ran stress analysis models. The results were clear-cut. That swarm wasn't random noise. It was a stick-slip propagation event, the exact signature that precedes major ruptures in other subduction zones. Before the 2011 Tohoku earthquake in Japan, magnitude 9.1, similar deep swarms occurred along the Japan Trench. Scientists identified them only after analyzing pre-event data. The patterns were nearly identical. But wait, there's more context nobody's talking about. On August 14, 2024, something happened 1,400 kilometers southeast of Puerto Rico that changed everything. A magnitude 7.3 earthquake struck the Lesser Antilles subduction zone near the island of Martinique. Damage was moderate, a few collapsed buildings, some road fractures. Within weeks, it disappeared from international news. But the energy release didn't disappear. Seismic waves from that rupture traveled through the Caribbean plate at 8 kilometers per second, arriving at the Puerto Rico Trench within minutes. When those waves hit the already stressed fault network, they acted like a geological trigger. Advanced finite element modeling conducted by researchers at the University of Puerto Rico shows that the August event increased Coulomb stress along the northern section of the trench by approximately 0.3 megapascals. That's enough to bring faults already near failure significantly closer to rupture. Within 3 weeks of the Martinique earthquake, Puerto Rico's seismic activity increased by 340%. Most were microtremors, magnitude 1.5 to 2.0, but they clustered along specific segments, migrated systematically northward, and occurred at depths that suggested magma interaction with fracture zones. Wait, did I just say magma? Yep. Most Caribbean disaster scenarios completely ignore something. The Puerto Rico Trench isn't just a seismic hazard, it's also a dormant volcanic arc. About 50 million years ago, the Caribbean experienced massive volcanism. That activity stopped around 30 million years ago when the subduction geometry changed. The volcanoes went quiet, cities were built, resorts appeared on their slopes, but the magma chambers didn't vanish. They cooled, crystallized, became underground reservoirs of semi-solid rock sitting at temperatures around 800 degrees Celsius. Recent surveys, which detect underground electrical conductivity, found something deeply concerning. Beneath the central Puerto Rican Cordillera, approximately 15 to 20 kilometers down, there are anomalous high conductivity zones. In volcanic terms, that's like the signature of partial melt. Magma that's heated enough to start flowing again. A major earthquake along the trench could do more than shake buildings and trigger tsunamis. It could reactivate volcanic systems that have been dormant for millions of years. Sounds far-fetched? In 2011, the Tohoku earthquake didn't just devastate Japan's coast, it also triggered volcanic unrest at multiple Japanese volcanoes previously considered stable, including Mount Fuji. The Puerto Rico Trench's next major earthquake could pull the same trick. Let's talk about the tsunami scenario everyone's afraid to model accurately. The standard assumption goes like this. A magnitude 8.0 earthquake ruptures the trench. Seafloor displacement generates a tsunami. Wave heights reach 5 to 10 meters. Coastal areas get 15 minutes of warning. Damage is severe but manageable. That's the optimistic version. Here's what recent bathymetric mapping revealed. The northern wall of the Puerto Rico Trench is covered in massive submarine landslide scars. I'm talking about debris fields 50 kilometers long and 10 kilometers wide. Geological evidence suggests these failures occurred during past megaquakes, when violent shaking destabilized the steep underwater slopes. One particular scar, designated the Arecibo Amphitheater, shows evidence of a prehistoric landslide that moved approximately 400 cubic kilometers of material. For scale, that's like twice the volume of Mount St. Helens' 1980 eruption. If a similar submarine landslide occurs during the next major earthquake, the tsunami wouldn't be a simple displacement wave. It would be a splash tsunami, the kind generated when massive volumes of rock suddenly collapse into deep water. Modeling conducted by the National Oceanic and Atmospheric Administration suggests such an event could produce initial wave heights exceeding 30 meters in some coastal areas. Not 30 meters offshore, 30 meters at the coastline. March 2025. The 47 earthquakes I mentioned earlier, they weren't evenly distributed. Seismologists mapping their epicenters found something that made zero sense under standard tectonic models. The tremors formed two distinct lines, one following the main trench axis, the other cutting perpendicular through Puerto Rico's interior, tracing the path of the Cerro Godin Fault, a strike-slip system running east-west across the island's center. Two different fault systems, activating simultaneously. Dr. Krista von Hillebrandt Andrade, who manages the Caribbean Tsunami Warning Program, put it bluntly during a March conference. We're seeing fault interaction we didn't know was possible here. The trench is communicating with inland faults in real time. She is basically saying a megaquake along the trench could trigger secondary ruptures inland, magnifying destruction far beyond the coast. But wait, let's get specific about what that actually means. Puerto Rico has roughly 3.2 million residents. About 2.4 million live within 10 kilometers of the coast. The island's infrastructure, from highways to hospitals, was largely built between 1950 and 1980 before modern seismic codes existed. The capital, San Juan, sits on a narrow coastal plain backed by steep hills. Most buildings are reinforced concrete, but the reinforcement standards used decades ago are now known to be inadequate for magnitude 8.0 plus events. A recent study identified approximately 8,500 buildings in the San Juan metropolitan area that would likely experience structural collapse in a magnitude 8.0 earthquake. Not damage, collapse. The island has 69 hospitals. Only 14 have been retrofitted to current seismic standards. The rest would likely lose operational capacity within minutes of a major quake. Water infrastructure? San Juan depends on the Caraizo Reservoir, fed by the Loiza River through a system of dams and aqueducts built in the 1950s. The main aqueduct crosses the Cerro Godin Fault in 3 locations. Analysis suggests it would rupture during a magnitude 7.5 plus event, cutting water supply to nearly 1 million people. Next comes the power grid. Puerto Rico's electrical system, already fragile after Hurricane Maria, relies on aging transmission towers and substations concentrated along the northern coast. A major earthquake combined with tsunami inundation would likely destroy 60 to 70% of the island's generation and distribution capacity. Don't go anywhere, because this is getting personal. In September 2017, when Hurricane Maria approached, Puerto Rico executed the largest hurricane evacuation in Caribbean history. Roads jammed, airports overflowed, ferries ran continuous schedules. It took 4 days to evacuate vulnerable coastal populations. 4 days of warning, because weather forecasting gave authorities nearly a week of lead time. For a Puerto Rico trench megaquake, the island would have 0 warning. Shake Alert, the earthquake early warning system used in California, can provide 10 to 30 seconds of warning before strong shaking arrives. Puerto Rico's seismic network, while functional, lacks the density and real-time processing capability to offer meaningful public alerts. Even if warnings worked perfectly, what's anyone supposed to do with 30 seconds? Evacuate a hospital? Shut down a chemical plant? Get children out of schools? The brutal reality is that 2.4 million coastal residents would face the earthquake with essentially no preparation. Those who survived the initial shaking would then have approximately 15 minutes before the tsunami arrives. 15 minutes to move inland, through debris-choked streets, past collapsed buildings, with no power, no communications, and no clear evacuation routes. Let's zoom out for a second and talk about something nobody's discussing publicly. Puerto Rico is broke. Like seriously, the island declared a form of municipal bankruptcy in 2017 with roughly $74 billion in debt and $49 billion in pension obligations. Recovery from Hurricane Maria cost an estimated $90 billion. The island's economy has been shrinking for nearly 2 decades. Now imagine a magnitude 8.0 plus earthquake and tsunami. The USGS Haywired scenario modeled a similar event for the San Francisco Bay Area and estimated economic losses at $200 billion. But the Bay Area has significantly better infrastructure, emergency response capabilities, and financial resources than Puerto Rico. A conservative estimate for Puerto Rico? Economic losses would exceed $150 billion. That's like 150% of the island's entire GDP. Recovery wouldn't take years. It would take decades. That's assuming federal aid flows at levels similar to post-Maria assistance, which arrived slowly and remains incomplete even now. But wait, here's the real scary economic dimension. Puerto Rico's location makes it a critical logistics hub. The Port of San Juan handles approximately 10 million tons of cargo annually, though much of it essential supplies for the eastern Caribbean islands. Destruction of port facilities would create a regional humanitarian crisis, affecting millions beyond Puerto Rico itself. Right now, this moment, at the time you're watching this video, stress is accumulating along the Puerto Rico Trench at approximately 19 millimeters per year. That's slow, imperceptible, until it isn't. The last confirmed megaquake on this fault system was May 2nd, 1787, magnitude 8.1. The tsunami that followed killed hundreds and destroyed coastal settlements across the northeastern Caribbean. Geological evidence suggests the average recurrence interval for these events is between 300 and 800 years, which means the trench could rupture tomorrow, or it could remain quiet for another 5 centuries. Except the recent acceleration changes that calculation. When GPS data shows faster than expected plate motion, when seismic swarms cluster in patterns that mirror pre-rupture sequences elsewhere, when stress transfer from distant earthquakes pushes already loaded faults closer to failure, the probabilities shift. A 2025 probabilistic seismic hazard assessment conducted by the Puerto Rico Seismic Network calculated a 12% probability of a magnitude 7.5 plus earthquake in the next 30 years. It's roughly the same probability California assigns to the San Andreas Fault. And we know Puerto Rico has a fraction of California's preparedness infrastructure. In a windowless lab in Mayagüez, Dr. Vanacor's team is doing something unprecedented. They're attempting to map the Puerto Rico Trench's internal structure in real time using a technique called ambient noise tomography. Instead of waiting for earthquakes to generate seismic waves they can analyze, they're using the constant background vibration of ocean waves, storms, and human activity to essentially echolocate the fault's geometry. The preliminary results are, let me say, complicated. They've identified at least 7 distinct fault segments that could rupture independently or together. The boundaries between these segments appear to be zones of high fluid pressure, possibly pressurized seawater that's been dragged down into the subduction zone. Now, why does this matter? Fluid pressure reduces friction. When friction drops, faults slip more easily. Those high-pressure zones could act as triggers, allowing rupture to cascade from one segment to another in a mechanism seismologists call fault unzipping. If the entire trench ruptures in a single event, you're looking at a potential magnitude 8.7 or greater. For scale, the 2004 Indian Ocean earthquake that generated the Boxing Day tsunami was magnitude 9.1. Every scientist knows that the Puerto Rico Trench has been remarkably quiet for 2 centuries. Sure, there have been moderate earthquakes, like the 1918 magnitude 7.3 event, but nothing approaching the prehistoric megaquakes carved into the geological record. That silence is actually deceiving. Seismologists call this a seismic gap, a section of active fault that hasn't ruptured in longer than the statistical average predicts. These gaps don't indicate safety. They indicate accumulated stress. The longer a fault remains locked, the larger the eventual earthquake. Japan's Tohoku earthquake occurred along a segment of the Japan Trench that had been relatively quiet for centuries. When it finally ruptured in 2011, it produced a magnitude 9.1, far larger than most models had predicted for that region. The Puerto Rico Trench could be following the same script. Let me walk you through what the actual event might look like. It's 2:47 a.m. on a random Tuesday. Most of Puerto Rico is asleep. Then, without warning, the trench ruptures. The first seismic waves, called P waves, arrive within 8 seconds. These are compression waves that cause a sharp jolt, like the ground has been punched from below. Objects rattle. Car alarms trigger. Light sleepers wake. Then come the S waves, shear waves that cause the real damage. They arrive approximately 15 seconds after the P waves and last 3 to 5 minutes. The ground doesn't just shake, it moves, sideways, vertically, in rolling motions that buckle roads and topple structures. Peak ground acceleration in coastal areas could exceed 1.2 g, 1.2 times the force of gravity. That's strong enough to throw people off their feet, strong enough to snap the base connections of buildings not designed for such forces. Landslides begin immediately. Entire hillsides collapse, burying highways and communities in their path. In San Juan, the shaking triggers a horrifying chain reaction. Older apartment buildings, their concrete weakened by decades of salt air and inadequate maintenance, begin to pancake. The Luis Muñoz Marine International Airport, built on reclaimed land in Bayfill, experiences severe liquefaction. The runway surface ripples like water, grounding the entire aviation fleet just when it's needed most. Then, approximately 12 minutes after the shaking stops, the ocean begins its deadly retreat. Fishermen notice it first, the water pulling back, reefs emerging, boats grounding on suddenly exposed seabed. This withdrawal is the tsunami's signature. As the wave approaches shore, it draws water toward itself, creating the illusion that the sea is draining away. Then it arrives, not as a single wall of water, but as a series of waves. The first might be 5 meters high, the second 12 meters, the third the largest, potentially reaching 20 meters or more in amplified zones. The wave doesn't crash like a surfing break, it surges, a rising flood that keeps rising, pushing inland with the force of an entire ocean behind it. Cars, boats, shipping containers, downed trees, everything becomes projectiles. The water carries them miles inland, smashing through buildings, sweeping away survivors who escaped the earthquake's initial destruction. Coastal neighborhoods simply cease to exist. Erased. We've spent literally billions studying earthquake prediction, deployed thousands of sensors, created sophisticated models, and we still can't answer the simple question, when? The Puerto Rico Trench will rupture. The tsunami will come. These aren't possibilities, they're certainties written into the physics of plate tectonics. The 47 earthquakes detected in March down 2025 might be the beginning of that process. Or they might be another false alarm, another swarm that fades into geological background noise. What's clear is this: the Atlantic's deepest fault is moving, building towards something the Caribbean hasn't experienced in over 2 centuries. So what do you think? Are these recent swarms the opening act of the Atlantic's next great earthquake? Or is the trench simply doing what it's done for millennia, creeping, groaning, but never quite breaking? Drop your theory in the comments, because honestly, we're all trying to figure this out together. Subscribe for more mysteries that challenge what we think we know about our planet, and check out the next video here.